good conversation at Scribe, and I'm hoping to have more interaction with them. Maybe some kind of exploratory project to look at putting Big Chain DB underneath as a source. Hey, Kit, as a storage, as one of the storage options for RChain, for the local storage. So that could be quite interesting. Also, we had really good conversations with Peter Harris from Resonate.io, and would really be very interested in looking at them as one of the potential first applications sitting on top of the RChain platform. They do a music sharing, music streaming service. So this would be a really, really good test of the scaling of RChain. And they're quite interested in this, so we're going to be setting up some follow-up discussions to see how that goes. Unfortunately, I wasn't able to meet with Jack. He was on vacation when I got there. But that's just sometimes scheduling things are just impossible. Can't meet all the schedules. But I think overall it was a very successful trip. I think these two potential partnerships could be quite helpful in upcoming development. So then also I spent a good deal of time working on a white paper for RChain that's a little bit less technical and builds upon some of the ideas that I touched on in the last discussion, last community hangout. So I'll share just the introduction with you guys maybe a little bit later in today's hangout. But it should be up and running. One of the phrases that up and available for commentary by the beginning of next week. One of the phrases that sort of landed home with me was "E pluribus unum 2.0." And I know Ed likes that, and I've been getting positive feedback from other folks. Essentially the thought is, that the blockchain offers us a way of being one of many, a new way of being one of many, which is kind of what I see as critical to be able to respond effectively to what's happening as a result of climate change. So that's the. Sort of a couple of different design options for the VM rewrite in Scala. I'm looking at the other applications of writing it in Scala. Of course, one of those is we go with the garbage collection, which would be really nice. But I want to dive into the code and kind of give people a clearer understanding of what some of the design trade-offs are. And basically they come down to something that is more clearly an executable specification versus something that might perform better, and kind of looking at the trade-offs there. So like I said, we'll do more of a deep dive on the at the code level of the trade-offs a little bit later. Also, Mike and I spent some time doing a more detailed analysis of K framework. I have to say that it's kind of like a lot of these things. It's a lot more fiddly, a lot less turnkey than I wish it were. The other thing is that as soon as they decided to become more focused on industry and a little less focused on where the industry will be heading, they lost touch with concurrency. So A lot of their examples, in fact, 99% of their examples are based upon sequential rewrite semantics. And they don't have a lot of support anymore for the concurrency semantics. So we're trying to boil that down into some nice, crisp feature discussions with the K-Frameworks people. And here's one of those tricky moments in software development, these kinds of tricky decisions. Sort of fish or cut bait kind of decisions. We could easily go with a different framework. For example, having done more of a deep dive on K-Framework, it's pretty clear that they're bootstrapping off of mod. And I used mod pretty extensively about 12 years ago, and I know Carolyn Talcott quite well, or at least we've worked together on several occasions. So we could go with something that's more closer to the origins of the ideas that K-Framework is bootstrapping off of. But I think because of the depth of the organization and their commitment, I think, to the industry and bringing formal semantics to the industry, it's better to double down and help them get the features that they need in order to support us, rather than to kind of jump ship after this initial analysis of what they actually support in practice. So that's kind of the plan for now. I'm happy.
Greg, I lost your audio.
Yeah, me too.
To interesting. Hello.
Can hear you now.
You can hear me now?
Yeah, but you were off for about 40 seconds or something.
Okay, what was the last thing you heard me say?
You're very happy.
Right before that, I'm happy about a lot of things.
you were.
Yeah, I'm happy to have more private discussions about K-Framework.
Yeah, you were talking about bootstrapping off a mod. Yeah.
Yeah. So like I said, I think that the right decision here is to double down on K-Framework and help them get to the kind of feature set that we want, in order to provide the kinds of semantic specifications that we want. I think that they're receptive to that. I think they have an organizational depth and persistence that will respond well to that kind of engagement and dialogue. So that's where we are. Those are the decisions, but I'm also happy to discuss those trade-offs with anyone and see if the community has a different opinion. But that's sort of where things are, at least in my mind right now. Let's see. Ed, do you have any updates you want to talk about?
Sure thing. Hi, everyone. Let's see. So in tuning up for questions that we're getting from investors, I'm going to be working on the architecture document. I haven't actually done a careful read of it since like January. And I know that it's missing some topics in the depth I would like to see, such as how the staking tokens and secondary tokens are handled in the supply, for example. And I just would like to call out to those that are interested in the architecture document. Would love your feedback in these next couple of days about it, if in either specific or just general, to say, this section I'm confused about, or something like that. Or if you want to collaborate more closely, just reach out to me privately. That would be awesome. I'll probably do the bulk of that work over the weekend. We're going to have a meetup in Seattle on RChain the evening of the 31st. We've done, this will be the third of these. We did one in January and then in April, and we're doing another one at the end of this month. So I'll announce that. Evan and I have been talking about the idea of doing a hackathon, which would be a hackathon around business ideas, business case, user experience, and if there's a code that's meaningful at that time from a developer perspective in the context of a hackathon, would include that too. The idea is that that would be late September in Seattle. And then and the objectives would be several things. One is to just, it would be called a blockchain hackathon so that we get a broader audience. But it has the hidden objective that, RChain Holdings probably would sponsor part of it. And there's another potential sponsor in the Seattle area. And
So,
that.
Did you intend to hold that when I'm not here?
No, I didn't. I had that late September you'd be back.
Yeah, so we're back on October 2nd.
Oh, okay. So we may need to tweak that. No, I didn't intend that. I didn't have the dates right for your absence or out your honeymoon. Okay, so maybe it'll be October.
Or maybe you just want me out of the way. So
No. We want you there. Absolutely want you there. Yeah, I had you back like a week, almost a week earlier. But so anyway, the objectives are to make people more aware of RChain, make more people aware of RChain, look for business ideas and have conversations even around business ideas we've thought of in the blockchain space, and actually looking for teams and individuals who can join some RChain effort would be a great win at that as well. So look for more about that. The RChain Holdings established a contract with a guy named Lawrence Lerner. Lawrence, are you on? Doesn't appear to be. He's traveling in New York at the moment, and we'll be meeting with Nathan Windsor out there and other things. Lawrence has got a great background. He worked and managed a large team at PwC, including music and streaming audio for them, as well as another company, Cognizant. And so his goal is, my goals for him rather are to do business development, business case assessment, networking and awareness building about RChain, and some evangelism as well. So we'll get him on one of these weeks, hopefully next week, and do a more thorough introduction. But I'm delighted to have Lawrence on board. Nathan is doing a branding exercise of the RChain platform. Nathan, are you on? He is not. Okay. So maybe he'll join later. I'm going to try to reach him because I would love for him to be part of the conversation. Maybe later in the call we can talk about the themes, a particular couple of keywords or phrases and feelings we want to convey when we talk about RChain from a marketing perspective. And then that will inform a bunch of the message and artwork and so forth around the RChain platform. Is Navneet on? Hey, you are on. Navneet, you're on mute. Hi.
Yes, hi. Hi, everyone.
So as part of making rocks useful, there's a goal about making rocks somewhat useful in order to gain attention for it, and in order to some of the development team, especially on the holdings and LivelyGig side, to become more aware of how the Ethereum context works, so that we can then understand the requirements that we'll have on the RChain platform. But in addition, it's from a legal perspective, it's very helpful if rocks have a purpose beyond speculation. And that helps to reduce our risks of not being in compliance with securities regulations. So Greg and I and Navneet and others over the last few weeks have talked about, well, what kinds of applications would be helpful? And we're looking for something pretty trivial. One of the applications thought about was to have some kind of a paywall in front of YouTube videos around training or around the what's now Rolang.org beginning of a REPL, which is a simple development environment. You could think of it that way. And Greg and I were talking yesterday, and he brought up an excellent point and reminder, which is what we want to have in terms of the use of cryptocurrency, and especially the application tokens in the future, are ones that accelerate adoption. So to put up a paywall actually thwarts adoption. And so just to get off on the right foot, what can we do that is more of an accelerant? And so one of the ideas that he and I talked, and then Navneet and Glenn and I continued talking about yesterday afternoon, was some kind of a voting system where so Navneet, you want to continue talking about the specific idea, or would you like me to continue? You're on mute.
Actually, I'm driving. If you continue, that would be better, I guess.
Oh, okay, very good. Drive safe. The concept that we talked about was to have a very simple web page that would require use through either Mist or possibly MetaMask or possibly Parity, but would use the wallet applications and Web3 or F.js kind of application, and then would come up with a page that would you'd be able to specify a GitHub issue and then indicate that you want to upvote. And then when you click the vote button, it would prompt the wallet application for a commitment in ROC. And this would be in like dust of ROC, like 0.0000001 ROC, to register your vote. And then that would get registered then on an Ethereum smart contract that would be pretty simple. The Ethereum smart contract would just list the GitHub issue URL, probably the address that's voting, and the timestamp or something of that, and maybe the amount. And that would be the simple contract. And then the web page would be able to tally for any particular issue what the number of upvotes are. So this is one example. This is the best example we've come up with so far that's very simple, that has the objective of showing rocks are useful. And by the way, the RChain holding company could put out a bounty for delivering this. I'm curious of all your reactions to this idea.
I should probably abstain.
Because GitHub is centralized, probably.
This is a way for me to give someone rock, or this rock comes out of your treasury.
Well, no, you would give someone rock. There would be a recipient of this rock, either RChain holding or maybe even the developer of this program. It would provide usefulness. We could deliver it pretty quickly. And again, part of this is educational for us. And part of it is to have some simple demonstration that we can get to in a few weeks from now.
I mean, the other thing I would like to do is to make sure that, you know, the conversation remains alive over on the Slack channel or other channels.
Yeah, very good. So I'll summarize this there, or ask Navneet to do that. And then let's have that follow up. We don't need to take a lot of time here, and we're open to other ideas. But we, again, we want to make it fairly simple and something we can deliver. And this is the first of potentially many of these kinds of ideas. So moving on, I just wanted to acknowledge again Patrick and Kit Blake's contributions on the FAQ. It'd be great to hear from one of you about your intentions for next steps on that. One of my concerns is we need to be very careful during fundraising about what we say through our official channels, especially about, for example, future tokens, about what the tokens ROC and Rev represent, and the supply and those kinds of topics. So there's some sensitivities. But Patrick or Kit, would you like to talk about that?
Sure. I'll jump in unless Patrick wants to say something. Hi.
Hey.
Our thinking for the FAQ is that it should be somewhere public, and the somewhere is the question. If we want it in a very obvious, easy to find place, then we would put it on the website, so it would just be available in the navigation, and people would come across it as they go through the site. However, we've also discussed just keeping it on GitHub, which is partially for management of the content, so that various people can easily add new questions and answers as they come up. But if we keep it in Markdown, then it'll also be perfectly readable on GitHub. And personally, I find that somewhat attractive. There's a nice attitude there in terms of having our FAQ publicly readable, but on GitHub.
Yeah, thank you. I tend to agree with all that. It's important that those messages be controlled. Maybe long term there's a knowledge-based solution with a very nice presentation that it evolves to set an index into the most frequent knowledge-based articles. But for now, I think something simple is great that has some controls around it.
Yeah, I'm with you on that.
Cool. So yeah, I'm happy to help to get that visible, because we're going to get more and more eyes on RChain in the coming weeks and months. Oh, cool. So I think that's my update. I'm happy to address any other questions.
Thanks, Ed. That was really good. I very much appreciate that. I also wanted to mention that Lisa has been very diligent in dragging all the financials out of my pea brain. So hopefully we'll have also a nice QuickBooks view of all the transactions. Of course, everything to date is viewable on the blockchain, or on between the Bitcoin and Ethereum blockchains. They're all visible. But it'll be good to have the QuickBooks markings with the corresponding contracts and other efforts associated with the co-op activities. So very, very happy about that. Very grateful. We're getting to the point where we're starting to nail down a process whereby we have the proper controls in place, and kind of the right signatory authority associated with the process. It will mean, and I'll mention this to everyone, but it will mean that instead of sending me invoices and those kinds of things, the invoices should go to Lisa and HJ with me CC'd. So that'll be a small change for people who are submitting invoices to the co-op. But I'll be contacting you individually about that as well. Okay, so those are some of the major updates.
If there's time, I have updates on the cost schedule.
Oh, yay. Well, please Give us an update.
Sure. So I've been working recently to try to nail down some of the, I guess, a couple algorithms by which we could determine the cost of values during compilation, with, again, the overall theme being that we want to optimize based on our costs. So just to get a good foundation, I started with our value types. So, like if I have an integer or a float or what have you, how can I assign a cost to that during compilation or even included in the parser? So taking an approach from syntax-directed translation, and actually here I'll screen share really quick. Can you guys see?
Yes.
Sure. Okay. So this is kind of just like a kind of a toy model that I came up with just to exemplify the approach that we could take. But essentially the idea is, and it seems like the most efficient way to include costing mechanisms, at least for values, is going to be during type declarations. So on the right, you'll notice here, these are our grammar elements, although they're not exactly accurate to the specification of Rolang yet, but this basis should work just fine. And I guess I'll just walk through. So we begin. What we want to start with is essentially an initial cost. The cost of memory, so the cost of a word or storage, and the base address or the relative base address that we're using for whatever our value is. So we're going to start that with 0, but if this is, depending on where this is in the program, the offset could be, like whatever you want it to be, essentially. So we begin, I'll say, again, by establishing those, and then we have a declaration. So our declaration consists of a name, so an identifier, whatever you want to call your value, and then the type. So the first thing we're going to do is resolve the type. So when we resolve the type, it's either going to go to a base type or C, and I'll explain C in a second. But if it's a base type, let's say, for example, if your type's an integer, then B resolves down to an int here. And when we resolve B, we're going to perform this semantic action, which is essentially going to assign the type of B to an int. It's going to assign the size of B or the width of B as the amount of space that it occupies in memory. So 4 bytes is essentially, going from JVM standards, how Java will recognize an integer. And then the cost of this value is going to be the size of the value times however much we decided a word cost. So if we look up here and it's 1, then the cost of this is just going to be essentially 1. And that's actually, I guess, because assuming because obviously 4 bytes is a word. So after we resolve B up here, we're going to assign B to, or the values we just got, to a couple temporaries, and I'll explain that in a second. And after that, essentially assuming that each type declaration ends with an empty or a terminal value, we resolve the terminal. So that goes down to null, which I didn't really know how else to explain or how else to annotate a null value. So I just, or a terminal, so I just use null. And then we assign the temporaries to the type here. And then ultimately what happens is we assign the T or T's values for our type as the type of B, essentially, as the width of our int, and as the cost of our int. And then finally, when we resolve back up here, we create an entry for our symbol table. We include the name or our identifier, the type of T, the offset, right? So the address that we, the address that we decided. and then the cost. And we're going to increment our offset by the width of T and increment our cost by the cost of T. So using this schema, you essentially get the storage layout for local names, not quite global, but you get the storage layout for local names, you get a type declaration, and you get the cost of that value in a symbol table. So a similar thing works for arrays. If, say, now that our cost is 1 and our offset is 1 per word, then if we did an array with essentially the same approach, we would end up with the size of our array being the number of values that we have times the width of each value. So the elements times the width, and with the cost being similar. Interestingly, we can also do this for structs. So we can actually get the typing information for each field in the struct while maintaining the cost information and the storage layout for all fields in the struct. So the first thing we're going to do there is save our symbol table that we had up here, which already includes our int or array, whatever you have. And then we want to create a new symbol table. We want to save our offset. And then we want to set that offset to 0 and our cost to 0. So this is essentially just creating a new symbol table for whatever our struct is going to be. And then when we have our declaration or whatever types are included in the struct, we're going to kind of go through the same song and dance that we did earlier. We're going to create an offset for whatever that field inside the struct is. We're going to get a cost for whatever that field inside that struct is. And after that, we're going to assign the type of T to a struct that includes our table. So struct here being the struct constructor. And then we're going to take the width finally of whatever our struct is as the offset. So that's going to be the total of all the fields here. We're going to take the cost of all those total fields as the total cost for the struct. And then we're going to restore essentially our table and our offset. So at the end of this, you have kind of a granular view of the cost of data inside of structs, inside of arrays, and at the type level. And of course, like a lot of languages, they make use of type erasure. So this is assuming then that we, erase our types, that we preserve cost information. That's granted. But it's also useful, and it got me thinking about the possibility of doing unification and type matching kind of based on, or at least inspired by cost. So if, say, I wanted to, if I wanted to process data, or I got an input and I wanted to do a case class on that data, then it would also allow me, the data available would be cost. So for something coming in, if the cost of that data is this value, then continue processing, which is actually pretty useful when you consider like how mobile code will be on RChain. So it kind of introduces this like kind of weird, but very, very cool dynamic where the cost of your computation, if you want, is accessible. And a programmer and a Erlang programmer would also be kind of trained in how the cost schema on RChain works, which kind of introduces a new, like a new job description for whatever your programmer is. So then again, if just to kind of summarize, we have cost for values tied to our type declarations. We have cost for structs and for arrays and for all of the elements or for all the fields and elements of those structures respectively. Which seems like a solid basis. So that's what I got.
Cool. No, thank you for putting your thoughts together and trying to be as concrete and definite as possible.
Sure.
There are a bunch of questions that I have that are related to the way we think about this, multi-component notion of cost, right? So cost of cycles versus cost of memory versus cost of network.
Right.
And you kind of highlighted those here, and that's the right thing to do. But when we get down to the details, we're going to have to go through each of those cases. But in general, the scheme works as expected for all structural types that are built off of products and sums and a set of ground types.
Right. So again, I mean, this is just as a basis for whatever we have with our value types. So this is essentially just data, and like another thing that we would consider, for example, is that processes or definitions, however we say it, those take up or ideally would take up constant memory, right? Because every time, I mean, all we have to do is kind of reference the place where our definition resides and then pass it parameters. But each one of those contains constant memory. So you're right. This is definitely the difference between what we'd say are values and kind of memory-based costs, but it does not account for what we'd say are compute or instructions, operations, what have you. But yeah,
right. Yeah, exactly. I mean, this is a good beginning to reason about the cost of accessing or laying out or updating structural definitions that are products and sums built over a set of ground types. So yeah, this is good, very good.
Right. Cool.
So why don't we go from there to just a brief discussion. Mike and I were talking a little bit about a couple of different design points. Mike, are you still on?
Yeah, I'm here.
Do you want to screen share first and kind of walk through the initial design that you and I were talking about, and then I'll show the little sketch that I made, and then we'll talk about the trade-offs.
Sure, just a sec.
Okay. So essentially, what we're working on right now, while Mike is getting his screen up, is the methodology that we're using to rewrite the virtual machine is to go through the execute method in the C++ vm.cc and essentially rewrite that in Scala, and then use that to drive out exactly what surface area of the class hierarchy of Scala, of the Rosette implementation, we're actually going to need to port over just to get the VM up and running. So what Mike's got his screen on right now is the execute method in vm.cc. And you can kind of see, roughly it's just a big case switch statement.
So it has this label at the top, which most operations jump back to. So you can roughly think of it as a loop. There are, however, places like this where there are labels in the middle of the case statement that will get jumped to, or down here at the end, and so on. And at the very end is VM error or exit.
So you can think of this really as a state machine, and each of the labels are states that the actions transition to. Then Mike gave a fairly literal interpretation of that in terms of Scala.
So had case classes for the individual operations, the opcodes, and then I started with a do while loop for the next stop, various flags for the state that it's in, and then just a big match case statement here. All of the flag logic was at the end of the while loop.
And that's a perfectly reasonable implementation. And one of the set of trade-offs that we are considering is kind of this is likely to be much more performant. Now, an alternative methodology that I've used is, hang on a second, let me just grab the code. And I've used this for several virtual machines. We have a trait that's just about the transition function. And then just like with Mike, we have case classes for each of the different kinds of opcodes. And then there's an overarching trait called opcode that they each extend or mix in. And but the difference is that you have execute method for each different kind of opcode. So for example, here, this might be op halt. And then because it is possible that you're going to see an opcode as a part of the subsequent processing of op halt, or not op halt, but one of the other ones, say I can't remember the opcodes off the top of my head, but one of the other ones, you might do subsequent downstream processing of a code, and that will be typed opcode. So because it's typed opcode, you need to be able to dispatch off of that. So you come in at the highest level, and then all the case match does is to figure out which type it is and then call execute. So subsequent calls in here to next states would be to execute dispatch, and then execute dispatch would figure out essentially which execute method to call by dispatching on the type. And then finally, each of these are essentially one-step transitions, right? So it's execute, do one execution, and then execute star, which is the iterated loop, is basically reading off of a code stream and then calling execute dispatch, because what you get off the stream is an opcode. And then execute dispatch figures out which kind of opcode it is, and then just calls execute. So here, the disadvantage is that you're getting the multi-method. Rosette terminology creeping in. You're getting the generic function dispatch hit mixed in with the VM dispatch. So if Scala is really good at that, or if Java is really good at that, then it's not too much of an overhead. If Scala or Java are terrible at that, then it becomes a really big overhead. The advantage is that you now have type level control over dispatching, right? So you'll and notice that we've carefully done the dispatching in terms of the entire state of the VM. So rather than have the VM have members that are associated with its state, the state then becomes parameters to the execute functions, right? So here we can dispatch the code not only in terms of the bytecode itself, but if we have different contexts. For example, if later we have a context basically represent our continuations. If we have a persisted continuation or a delimited continuation, then we can add in a method execute that dispatches on that type, as opposed to the normal type of continuations that were originally associated with Rosette. So that gives you a flavor for the kinds of things we can do. And then we can also, if we have the flags that Mike was talking about, which essentially represent the different kind of state, we can dispatch at the type level on the different kinds of state. So essentially the big trade-off in terms of these two different design options is whether or not we push the specification as much as possible up into the type level. So then the types become a way of characterizing the transitions in the VM. Now, I like that personally, or I pursue that methodology vigorously because I like having type level control. Again, the downside of that is if the hosting language where you're doing this kind of implementation is not so good at generic function dispatch, then that can be a significant overhead.
Now, you're also, making the code more reusable, aren't you?
Yes, the code is more reusable in this style.
And so the whole system is simpler.
The whole system overall becomes more, more composable, more pipelinable. So yeah, it's simpler in that sense.
Would an alternative approach, if one wanted to, be to specify the opcodes themselves based on type?
The opcodes are already specified based on type.
Right.
Both approaches use that.
Gotcha.
The question is whether or not you use a runtime dispatching mechanism or use a compile time dispatching mechanism. Now, for most of these languages, once you have a top level type, that ends up shadowing your dispatching. So you have to have a kind of mix between compile time and runtime dispatch. So the execute dispatch is really the simplest, most sort of bare bones piece of the runtime dispatch. It's like, figure out the type right here, right now, and then call the appropriate polymorphic form of execute. And then each of the polymorphic forms of execute are then spelled out, right? So we'll have a bunch of these, one for each opcode.
Right, and then I'm assuming that the more we can kind of cram into the compile time type information, the more performant will become.
It depends upon some things that are going on under the hood of Scala and Java.
Right.
So Mike's implementation is likely to be faster depending upon how they do the basically the high order bit here is the style that's on the screen right now is executable specification style. The style that Mike was showing is a kind of optimized form. And what I hope to pursue in this phase of development is we'll have a reference implementation that's executable specification style. And then if we discover that that's simply not fast enough, we'll move over to the other style. And then we'll be able to construct an audit trail. Here's the original implementation. Here's an executable specification where we're respecting Curry Howard, and the types are telling us a lot about the behavior. And then from there we say, okay, but that's not quite fast enough, and then we move to something that's a little bit more like an inline state machine. So that's the methodology I prefer to pursue at this point. I don't think it adds too much in terms of overhead to the development cost, and what it gives us in terms of clarity of communication, I think is considerable. So but please, if there are differing opinions, please voice them in Slack, and we'll keep this conversation alive.
Yeah, my 50 years of experience tells me is that you don't program for efficiency initially, because programmers are almost never correct at where the time ends up being.
Yeah, you are preaching to the choir. Having committed, my fair share of early optimization mistakes. So yes, absolutely agreed. Okay. So then I'd like to close out by doing something. Let's see, someone was in the chat here. Let's see what we.
Yeah, I just wanted to welcome Branko. He's new to the Slack, and he's to the Zoom, and he's been interested. So we've got a couple emails from him. Branko, do you have a minute to say hi?
Yeah, can you guys hear me?
Quite well.
Hey everybody, my name is Branko. I come from Serbia. I have around 3 years of experience. I worked in a startup that was basically making a code generator from a textual language. So that's what kept me interested in this as well. I don't have any experience with the blockchain and cryptocurrencies, but I think I like it really much. So these days I'll try to take the subject and learn more about it.
Yeah, I think it's very cool that you have, if I remember your email, some Scala experience and some domain-specific language.
Yeah. So the generator we developed was in pure Scala, but for parser, we only used the parser combinator. We didn't write our own parsers.
Understood.
Yeah,
combinators are not particularly performant, as I discovered.
Yeah. Well, it was one-time compilation and code generation, so it wasn't about efficiency. It was more about readability.
Yeah, fair enough. Understood. Absolutely. Yeah. Let's see.
Well, welcome.
Yeah, welcome.
Thank you, guys. Nice to meet you all.
Yeah, thank you for your interest and like to to have you get more deep into the conversation.
Yeah, sure.
So I'm just going to share a little bit of the white paper, just the very, very beginning to whet your appetite for what's going to happen. I apologize. I'm just going to read it and get some commentary. I've kind of broached some of these ideas in last week's Hangout, but you'll get a flavor for where the white paper is heading. The overall the title of the paper is E Pluribus Unum 2.0. The rough outline of the paper is we've got introduction and motivation. Then we talk about the gamification of consensus. So that section is Games Without Frontiers. And then we talk a little bit about the history of computational agency, how this has been thought of throughout the centuries that we've thought about computation. Then there's also a discussion of the ladle algorithm and what this means in terms of collectivity. And then we discuss, then we tie that together with what it means when the replicated platforms are free, right? If you can press a button and get all of Ethereum all at once, what does that do to the market? What does that do to what we're trying to do? And then finally, we talk a little bit about the sort of where the value prop is in terms of applications. So the title of that section is called Applied Intelligence. And I'm just gonna, there's a page in a little bit, 2 pages in a little bit on the introduction and motivation that I'm going to share now, and then hopefully I'll unveil the whole paper by early next week. So who knows this one? I am calling, and you insert organizational entity here: bank, hospital, insurance company, federal governmental agency. I am calling because their online automated service doesn't handle my situation, and I need to talk with someone empowered to handle a more specific case. I have navigated an automated call routing menu some 10 levels deep, waited on hold for 20 minutes or more, spoken to a representative who does not have the information that was collected in the automated call routing system and is not empowered to handle my situation. And now I am on hold again, waiting to speak to someone else in the organization. And then the call is disconnected.
You've been there recently, right? Unfortunately.
That's right. This is not a short story by Kafka. This is a common experience. It is a common experience happening at the interface between organizational agency and individual agency, between institutions set up to serve people and individual persons they have been set up to serve, between the many and the one. So strictly speaking, it is a common experience we have collectively organized for ourselves and consented to participating in. The question is, can we do better? Can we have a better dialogue between the collective and the individual, between the many and the one? Surely there are plenty of examples in our common experience of this happening. One of the reasons we seek out live musical performances is to witness a more productive, more satisfying, more spontaneous, and more joyful engagement between individual performers and the ensembles they are playing in. One of the reasons we come away energized by these performances is because we have witnessed real and actual harmony, not just heard it with our ears, but felt its presence and participated in it. And the internet is expanding and amplifying not only the news of outbreaks of this other kind of dialogue, but also the possibility of participating in it, of consenting to a more whole, more harmonious engagement between the collective and the individual, between the many and the one. From people forming a human chain to save a family swept out to sea by a riptide, to people organizing to provide relief to Syrian refugees or protesting the denial of asylum to these refugees on the basis of religion, the new connectedness makes it possible to connect in qualitatively different ways. In a word, the internet has been the harbinger of a new way of being one of many, a new version of E Pluribus Unum. It is intriguing that this phrase should feature so prominently on a currency, because if the internet is the harbinger, then the blockchain is the manger. Beginning as a revolution in the role and function of currency in society, the blockchain and our understanding of its potential has evolved into a very tangible means for organizations to form and function, to become lively and quick instead of stagnant and deadening. To be sure, the original purpose of capital and currency as social technologies was to help us coordinate better, to help make it easier to take care of each other and the planet. This older coordination technology, however, has fatal flaws because the mechanism of currency creation, distribution, and maintenance is so labor and resource intensive that it can fall prey to hoarding and other forms of flow disruption and imbalance. So further, when this mechanism with its implicit requirements of trust in centralized third parties is replicated in digital form, these problems become greatly exacerbated and the resulting chain of negative consequences greatly accelerated. We've all witnessed this in the rapidly widening gap between the haves and the have-nots, with the number of haves falling well below the number of people that would safely fit in the contact list of a vintage year 2000 cell phone. Yet controlling more than 90% of the wealth of the entire planet, we see the decimation of democratic principles. The people are not coordinating amongst themselves, guiding their welfare, taking care of each other and the planet. Instead, the wealthy few are taking care of themselves, and in many cases are quite happy to let many go without access to healthcare, food, shelter, and other basic necessities. And this is not because the resources aren't there, but because the distribution of those resources is guided by ineffective organizational agencies carrying out the will of the few. The blockchain is a means by which we can overcome these inefficiencies. The new consensus algorithms offer us the opportunity to place ourselves back under the wings of our better angels, to put ourselves in help's way rather than merely getting us out of harm's way. Surprisingly, they do so by allowing individuals to be more themselves and not be coerced into trust relationships that compromise core values. This is the wholeness, the more completed vision that RChain serves, a new way of being one of many, an e pluribus unum 2.0. In order to realize this vision, several technical advances must all come together. If the Bitcoin blockchain's proof of work algorithm was something like HTTP 1.0, the HTTP 1.0 version of these new protocols, and Ethereum is the HTTP 1.1, we need something of an entirely different order to scale to the point where these protocols work at the throughput and volumes necessary to renew the global financial, compute, and governance infrastructures. In what follows, we are going to spell out in some detail what those technical advances are and how they fit together. However, before engaging that discussion, it's important to recognize that these developments come not a moment too soon. At the time of this writing, the data coming in about the dramatic changes in climate due to the impact of human civilization on our planet Earth is stark and sobering. If we are going to prevent catastrophic change, we have to organize ourselves and take effective action, and we are going to have to do this at a pace that is simply not possible using the incumbent coordination and governance technologies. It is no accident that these technologies have arrived at this moment of great need. We simply have to organize ourselves differently if we plan to enjoy a place on our gracious planet. Necessity is a mother. We will simply not remain in place, though. Instead, our place in this world and our understanding of that place is about to undergo a remarkable.
Greg, we lost your audio just now.
Remarkable transformation. To illustrate this transformation, can you guys hear me now? Can you hear me?
Yes, you were on remarkable transformation.
Thank you. To illustrate this transformation, alongside the discussion of the technical advancements needed to realize the RChain vision, we will look at the notion of agency and how the technical developments coincide with a progression of the notion of agency that can, at least in principle, keep pace with the changes induced on planetary climate by the incumbent civilization. So that's the introduction. and I welcome any commentary. I know we're over time, but I welcome any commentary, and I will have the draft up by beginning next week. Any last thought?
Well, I have to give some updates on that. We do have in our RChain test Mattermost instance content channel.
Thoughts, comments, questions?
Can you hear me?
Yes.
So there's a content weaving video here. I suggest everyone watch it. Show some of the social ledger work that's coming out of digital life. That has a awesome Mattermost integration that shows holonic, lets you browse the holonic structure of the organization and such. But there's definitely a must-watch video. As part of the discussion, one of the suggestions was to create a non-RChain affiliated co-op, and I realized the use of this logo here may be wrong. I just created it; I didn't add it to it. But the idea is that people could submit articles here, and perhaps if the article is accepted to be published by RChain, we could offer a bounty or something. So be sort of the voice of the community.
I like the idea. I like the idea of an RChain news feed, Jim. Like kind of like a topical thing that reflects moral opinions and stances. That's cool.
Yeah, that's a great idea.
But this is the community speaking, so it's they're not they can be guided to give the message, but essentially, I mean, there's different ways we can handle publication, and basically the group in the Mattermost channel is deciding that process, and this is running on a server we control on under Cloud on DigitalOcean. And Saturday morning, 11 a.m. New York time, we're having Andreas Freund in the identity circle, but he's also very active and knowledgeable in things like the cross-chain protocols and other things. But he's one of my identity idols. That's anything else from the community, Patrick?
This was a good meeting.
Indeed.
Yeah, and waiting to get your pages to give you some feedback. I think communications would be needs to be added to the financial and government and communications piece. It was wonderful. Yeah, at first I thought, wait, this isn't a white paper on RChain, and maybe it's not. And also the focus on climate change, I think, should be toned with other important concerns. It sort of identifies an extremist point of view that we may have, but we don't want to advertise.
Interesting. That's good. That's good feedback. Thank you. Awesome. So it's 12:07. I've got to chock-a-block commitments. So I'm going to jump off, but thank you so much. And whoever, please keep talking.